Morning, Cameron here, maths and physics teacher. I was doing some spreadsheet modelling, which you may have seen on the spread of coronavirus. Originally this was done for some students who weren't washing their hands and using hand sanitizers, and showing the importance of social isolation. I think we probably know that and how important it is now. Data and information is very powerful, and it's very powerful for predicting the future, but with this epidemic we don't know the full facts because we haven't tested lots of people. But what we do have that is a hard fact is the number of deaths, and that is showing a pattern. And in the United Kingdom at the minute, the number of deaths, the total number of deaths, is doubling every 4 days. So I thought I would put that into our model and see what infection rate that is giving. Now the infection rate here isn't 0.2. Excuse me. Now the infection rate of 0.2 means that every day an active case gives it to 0.2 people, or effectively every 5 people who've got it, an extra 1 gets it. So if you've got 1,000 people active, you get an extra 200 that day. And if we look at our total deaths in this model, it goes from 40 to 80 in 1, 2, 3, 4 days. But in the UK it's happening every 3 days. So if I change that rate to 0.25, well, let's put it 0.3 first. It shows you that the total death rate is 51, 2, 3, more than doubles. 100 to 245 in 3 days, that's too much. But if I put this about 0.25, then that shows me a death rate that is doubling pretty much 118,000 to 227. That's doubling pretty much every 3 days. Now what that shows me is, because the death rate has been doubling every 3 days, it shows me that the infection rate 14 days ago was 0.25, because we put a time lag in between 14 days between someone getting this and becoming quite ill and dying. Now that's quite a powerful tool, because our death rate will give us indications of what we have essentially done to our infection rate 14 days ago by introducing measures. It will give us a history of how successful they have been. And that can give us a lot of hope, because if we go to Italy, for example, which has been under lockdown for a long time now, total deaths 9,014 4 days ago. 1, 2, 3, 4, 6,005, 6, 7. Hang on. March the 20. Let's take it from March the 21st. 1, 2, 3, 4, 5, 6. Shows us the death rate in Italy. It's slowed to doubling every 6 days, rather than every 3 days. Now let's put that into our spreadsheet. We'll put an infection rate of 0.15. Let's see what happens to the total deaths. So to go from 200 to 400, 1, 2, 3, 4, 5, 6. From 400, 1, 2, 3, 4, 5, 6. Now that shows me probably the infection rate in Italy 14 days ago was at 0.15. Let's look at Spain, which again has been in lockdown for longer. Total deaths 5,000. How many days do we go back to take that? 2.5. Let's 1, 2, 3, 4. 4 days. Now, they didn't lock down as quickly as Italy. Let's take it 3,000. How many days back to 1800? 1, 2, 3. 3 and a bit. So you can see the death rate, the rate that the death rate is doubling at is slowly going down in Spain. It was every 3 days. It's gone to 4, 1, 2, 3, 4. Well, actually, it's more than 4. 2,300. 1, 2, 3, 4. It's slowing down, which is positive. So where Italy are at the minute, we've got an infection rate of 0.15, and hopefully that will slow further as the lockdown kicks in. If we look at the active cases with an infection rate of 0.15, let's see how that projects out. Between days 105 and 209. But it still peaks. It still peaks. Total deaths today. Probably the most important one, because it shows the pressure on the NHS on any one day, or the health service. Shows a peak of 6,000 dying in one day in 100 days time because we're on day 50. Now that is with an infection rate of 0.15. That's currently where Italy is, and Italy has had a lockdown in the north. I'm not sure the date of the total lockdown in Italy. It'll be interesting to follow this. We want that infection rate down. Maximum deaths today, 2,400. If we can get that infection down to 0.1. And that infection rate is at 0.1. Our total deaths is doubling. What's the time period? Let's go from 15 to 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually 14.9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we've reached a point where our death rate is doubling every 12 days, then this model predicts that our maximum deaths a day are about 2,000. And we can assume from that we're going to need possibly 10 times that many hospital beds. I don't know. ICU beds, intensive medicine. 0.8. My spreadsheet doesn't handle that, it goes negative, but that's good news. That means we've cut it off. If we get this infection rate below 0.1, it's good news. And the reason that is good news, and the reason my spreadsheet can't handle it, is because then more people start getting cured every day than are actually catching it. And that is an incredibly powerful moment, because that means our number of actual cases starts to fall. That's where we need to be. Because with this model, even with the herd immunity, we get down to 64 million people. We lose 1.5 million people. With an infection rate of 0.1, it means that people are still getting it quicker than people are getting better. So that's about the key figure. When we reach that, we've closed it off. Below that, we stop closing this thing down, temporarily at least. One other thing from this model is if we look at our total deaths, for example, in the UK, at the moment, 759, and it says 14,000 people have got it. But let's look at our model. $759, how many people have actually got it? Total cases, $52,000. That's an infection rate with 0.1. Let's remember the UK's was 0.25 actually, isn't it? Where we are at the minute, when we started, the death rate from those who got it 14 days ago, we can say the infection rate was 0.25. So if we look at total deaths, 750 odd here, it actually tells us that the total cases were nearer 612,000. According to this model, about 400, no, maybe 500,000 people have got it. 500,000 people have possibly already got this. My model says 162 people possibly died today. Let's look at the figures in the UK. Daily deaths, 181. There we go, it's not far off, is it? But it would suggest the total cases would be about 500,000. But the actual recorded cases are near 15, so when you times that by, gosh, 30? There are probably 30 more cases than we're recording. Just copy and paste that down. Now that's pretty good. A lot more people have got it than we thought we had, because I've based my herd immunity on total recorded cases, and actually K4 vulnerable population, I've changed my herd immunity. I just need to work out how I did that there. The actual infected rate, H5, percentage immune. K4, what's K4? Population, G5, K4 minus R4, yeah, total cases. If I change that to S4 and copy and paste it down, which is real actual cases, I think this is the first time my model is actually going to give us true figures. Probably how many people are going to get this and how many people are going to die, because now we're looking at real numbers have got it rather than those we've detected. Let's have a look and see what happens. Population, let's look at it. It was going down to 64 million. Yeah, wow. 65,974. 94, that gives, wow, that's incredible. So according to my model, with an infection rate of 0.25 where it was, our population goes down by 70,000. This thing kills 75,000 people. If we do it at 0.1, where we're hoping to, well, let's look at 0.15, where we were, where Italy is with the lockdown. Our population goes down to 65,931. We still lose about 70,000. So let's look at the graphs now. I'm going to put the infection rate at 0.15, which is where it seems to be with lockdown. Let's look at died today and total deaths. So we're going to lose 65,000 people possibly to this. But the died today figure which is the all important one, peaks at 2044. No, tell a lie. 2134, and that's on day 134. But we got things late. An infection rate of 0.2. Our died today figure peaks 3,400. Day 100. And where are we now? we are. Total deaths 700 and about day 64 according to this model. Now here's the key thing. We put in social distancing, and I reckon we've got the infection rate well down, and I think that is going to change the tide today. 4,400 on day 86. 20 days time this is going to peak. Today's the 28th of March. According to my model, this is going to peak 20 days from today, probably. And the peak deaths in a day are going to be about 4,500. And our total deaths are going to be about 75,000. If we can get our social isolating down, if we can really nail it, we still peak at 4,500. Well, no, actually, got a high. Where are we? Day 67. Let's put it back up here. If we can really nail our social isolating, our peak deaths are about still 4,400 on day 84. Oh no, it's not, because my immunity formula I haven't got that multiplied by Z4 and I need to put that in. Copy and paste that down, I do apologise. Okay. So let's put all these figures at 1. Actually, let me just copy and paste this formula down again. So let's just go through this again. An infection rate of 0.25, which is where we were. Our total deaths about 700, and if we're on day 63, died today is going to peak at about 4,400 on day 86. So in 20 days time we're going to get 4,500 deaths. Okay. But day 67 we're going to go back 7 days, we're going to take this right down. We've reduced our infection rate by a half by social distancing. Let's see what happens then. So we're on day 67, look. Here we are, total deaths, sorry, day 64. died today. Let's see what happens. We were peaking at 4,500. Wow. We've made it peak at 1,200 and it's on day 107. Total deaths were at 70,000. We've gone down to 60,000. Let's take our social distancing even better, so we've reduced the infection rate to 1/3 about a week ago. Suddenly our died today peaks at 690. In about a week's time. Now I don't think we got down in time. I think that's too late in the game. I think, well, let's hope. According to this model, and this is good news, really good news, if we are social isolating that started a week ago, we reduced our infection rate to 0.3 of what it was. So if we interacted with 1/3 less people, we have gone from a peak death rate of 4,400 to 410 in a day. And our total deaths have gone from 70,000 to 31,000. But most importantly, the died today curve, which is the number of people who are going to be in hospital beds and taking up lots of beds, peaks. Instead of at 4,000, peaks at 410. Now, I'm going to change this figure here, and I'm just going to give you what Italy has, which is 0.15. We had it at 0.25, so equals 0.2 equals 0.15. We said Italy on now, divided by 0.25. So that should be equals. What this effectively does is work out the factor that, so that's not right, is it? That should be 0.15, 0.6. So Italy has got this down to 0.6. We think. That gives them a peak died today, 2,162 on day 95. But we think they're going to get it lower than that. We think they're going to get that a lot lower. It'll be interesting if it actually gives their total deaths and their died today rate at what they actually are. Let's have a look, see how accurate my model is. So let's go to Italy. 9,000 deaths. Died today, 919. 9,000 deaths, total deaths. Died today, 1,200. So we're a little bit higher, which is good news. But at this rate it shows the peak for Italy. Maximum people dying today, day 93. But that's with the 0.15 rate, and we think it's going to go down to 0.3. We think we've got a really good social distancing thing going on. It really does show the power of social distancing, though. This figure here, if we reduce it by a third, we just the die-to-day rate just changes massively, as we've seen, and that's the number of people in hospitals taking up NHS beds and so forth. If we can get it down, look, 346 on day 75. If we can get it down to a third of what it was 2 weeks ago. Peak deaths 346. We were looking at 4,400. Incredible difference. Incredible difference. I'll just show you that again. So look, an infection rate of 0.25, which effectively gives us the model we have for our current death rate, so where we were 2 weeks ago probably. Our died today peaks at 4,400, and that would have happened in about 20 days' time. But social distancing on day 63 here in the UK. If we change this, if we suddenly go in, so if we halve our infection rate to 0.5, our died today peaks at 1,100. If we can get it down to a third, our died today peaks at, it's a much longer curve, but it peaks at 120, 125 a day. If we get it even lower than that with good social distancing, we get our cured rate starts to get bigger than our new cases today. Look, new cases today 1,700, cured rate 1,800. Look, by day 77 more people are getting better than are getting ill, and that's a quarter of our 0.25 initial infection rate. So if we can get our infection rate down to a quarter of what it was 2 weeks ago by this social distancing, the numbers start to fall, and the numbers start to fall rapidly. I'll leave you with that.